All right, last topic of Unit 2, 2.9, Transformations of Functions, Day 2. So last time you were transforming functions. We're just going to continue with that. Things are just going to look a little different. We're just going to get more practice with it. This is a pretty big topic. The Regents exam loves to ask questions about this. Transforming functions. Let's talk. All right. If the number's on the outside of the function, so it's just like hanging out on the end, like plus something, minus something, we are going to move it up or down. Okay, if it's inside the parentheses or like inside the function, like underneath the square root symbol or inside the absolute value bars, we're going to move left or right. Remember, this is always counterintuitive. So if it's positive, it'll actually move it left. If it's negative, it'll actually move it right. Or I shouldn't say positive. Adding moves it left. Right is negative or subtraction. Changing the coefficient. If it's a whole number, it's going to get thinner. It's going to get more narrow. A fraction will actually make it wider. If you think about the slope, if you're multiplying it by a big number like 5, it's going to make it grow faster. Same kind of theory applies here. A fraction would make it wider. It would grow at a slower rate. If it's a negative, remember it just flips over the x-axis. It's a reflection. Let's talk. Okay, describe what changes will happen to each parent function to become g of x based on what we know. All right, if we ever need to, we can graph these, but I'm going to try to do this without my calculator. But when you are doing this in your notes, we are definitely going to verify as much as we can. Okay, so number one is a linear function. The first thing is to talk about what is different. We are multiplying the x by 2 and subtracting 5. So the 2 is going to, well, instead of saying making this thinner, it's going to make it, the slope will be steeper. So let's say steeper slope. That's what the 2 is doing. And then the minus 5 is going to shift down 5. Okay, quadratic functions. Why does this look different? Okay, there's a plus 8 inside with that little x guy right there, and there's a negative out in front. Let's talk first. What does a negative do? Yes, it reflects over the x-axis. And then what about the plus 8 inside the parentheses? Inside the parentheses, left or right. Okay, if it's plus 8, is it going to move it left or right? Plus 8, is it going to move it left or right? Positive addition, it's going to move left. Oops, left 8 units. And when I say it, we're moving the parent function, right? F of x moves left 8 units. F of x is going to be reflected over the x-axis, the parent function. Here's 3 examples that have been done for us in here. Let's just kind of talk through them real quick. That 1/2 is going to make it wider. The plus 4 on the outside is going to move it up 4. In this case, plus 1 is going to move it to the left. It's inside the function. That's super tricky, but that's what it does, because that's technically inside the parentheses, if you want to think about that as being with the exponent inside the parentheses. And then the plus 3 is going to shift it up. In our cube root function, that minus 2 inside the function, in this case underneath the cube root symbol, is going to move it right to the minus 7, will move it down 7. Okay, cubic function. Let's see what's going on here. We're adding 7 inside, subtracting 1 on the outside. So let's write this in some really special notation. G of x is shifted. What's the 7 going to do? 7 left and 1 down. Cool. Square root function, very similar to the cube root function. Oh, where'd that go? I need my bar. Okay, my drawing bar went away, but it's back now. Yay. All right, so minus 10 under the square root, minus 14 on the outside. What's it going to do? What's it going to do? Well, g of x is shifted how? 10 what? Yes, 10 right, because it's a minus. And what about the 14? 14 down. On the outside, it does exactly what we think, but remember on the inside, it always does the opposite. So a minus 10, 10 to the right. Ooh, look at this quadratic. This one's a little spicy. We got 1, 2, 3 changes. Okay, so what is happening? What is happening? G of x is, what is that 3 doing? Narrower, okay. So g of x is narrower. Plus 2, what's that going to do? Left 2 and 9 up. All right, let's check out some multiple choice questions here. So which is the equation of a parabola that has the same vertex? Okay, meaning that the parabola hasn't moved left or right or up or down, it's just there. And the parabola, as the parabola, blah, 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 represented by y equals x squared, but wider. Okay, that's up to, we don't like it. That's down to, we don't like it. Okay, so which one will make it wider? We want a number that is going to make a fraction less, or the function less steep, which is a fraction 1/2. 2 would actually make it skinnier. Okay, 10. Given the graph of the line represented by f of x is equal to negative 2x plus b, okay, if b is increased by 4 units, what is going to happen to the graph? It's on the outside. So if it's increased by 4, we're adding 4, which means our function is going to move up 4. All right, 11, here we go. How is the graph of blah, 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 blah? Well, I should not say that. I should really read it. Y equals x squared plus 4x plus 3. How is it affected when the coefficient, okay, remember the coefficient is the number in front of x squared. Okay, so this number is changed to a smaller positive number. Well, right now it's 1. So smaller positive would have to be a fraction. So let's just pick a random example, like 1/5. What's going to happen? Oh, yes. The 1/5, what's it going to do? It is definitely going to make it wider. So answer choice 3 and 4 are gone because 1 and 2 say wider. And the y-intercept, is the graph going to move left or right? Is it shifted if we just change the number out in front? No, no, no. So the y-intercept would stay the same. Oh, wait. No. Oh my gosh. This is a really good question. You know what? Let's use our calculator. I think this is going to be a really cool question. Yeah, you guys think I'm such a nerd. I am. It's okay. But I like this one. This is like a thinking question. It's making me think, which is great. Although I don't know. It's 8:30 on a Sunday night, and I just want to go to bed. But let's do this math. We just need to finish the video. Okay, here's the original, all right? And what they're saying to do is to create a new one that has like a fractional coefficient. And we decided to pick 1/5 x squared plus 4x plus 3. Let's see. Oh no, what did I do? Oh, I didn't do anything except we just need to look at what? A bigger window, don't I? Like negative 40. Let's see if that gives us a little bit more of a parabola. Let's see if it'll let me change that to maybe negative, I don't know, negative 30. Is that going to squeeze it in there? Sure is. I could also drag and grab or hit Control T, but really, where is the y-intercept in both of those fractions, or both of those functions? Why do I keep saying fractions and functions? Is it because they both start with an F? I don't know. But the y-intercept actually stays the same. So it does what I thought it was going to do, and then I second guess myself because I'm tired, but this is a perfect question to use our calculator on, and I just modeled it for you. How cool is that? Okay, question 12. A quadratic function can be modeled. F of x is equal to x squared minus 4. The function g of x, defined as g of x is equal to f of x plus 3. What is the equation of g of x in terms of x? Okay, this is kind of cool. Well, anytime we see f of x is the same thing as x squared minus 4, right? So g of x is really going to equal x squared minus 4, and then we just have to bring down that plus 3. So let's finish this off. G of x is equal to x squared minus 1. I'm just grouping together those cool little constants of minus 4 and 3. Okay, number 13. The vertex of this parabola has the coordinates of 2, -1. Find the coordinates of the vertex of the parabola defined as g of x is equal to f of x minus 2. You know what? We can use a graph paper, but I'm not going to use it. What happens if we see a minus 2 inside the parentheses? Yes, yes, yes. It moves left 2. So f of x shifts or shifted 2 to the right. Okay, so it's moving 2 to the right. Did I say 2 to the left? I feel like I said 2 to the left. I didn't mean that. It goes 2 to the right if I said that. Sorry if I did. I can't. My brain. Okay, so f of x shifted 2 to the right to become g of x. Okay, so if we look at the point 2, -1, and we're looking at shifting something 2 to the right, well, maybe this is why the graph paper, I'm going to actually use this just to show us. So this is the point 2, -1. Let's move that point 2 to the right. So if we're going to move it 2 to the right, 1, 2, it's going to be this point here. It's going to become the point 4, -1. And a way that we can just show that is if we're moving 2 to the right, we would add 2 there. So explain how we arrived at our answer. That's this here. So f of x shifted 2 to the right to become g of x. There is the new beautiful point.